طيب, okay. So we'll talk about the physical layer. So many concepts, many terms, the media data or the media, the copper cable, unshielded twisted pair, fiber optic cable, wireless media, to be discussed today. Now, when we talk about the physical layer, why? What's the main purpose of the physical layer? As you see now, we are talking about the OSI reference model. The OSI reference model, not the TCP reference model. Why we need the physical layer? What's the purpose? Before any network communication can occur, the physical connection to the local network must be established. We need a connection. Physically, we can use the wireless connection, so we need a physical connection. This connection between the source and the destination of the message can be wired or it can be wireless, depending on the infrastructure or how we set up our network. In general, or this in general applies whether you are considering corporate office or a home. So we need, when we talk about the home network, we talk about the home office network, we need a physical connection between the devices. Now, which device or what's the part, the hardware that will be used to connect the device to the network? We will use the network interface card, and we have talked about this before. So network interface card, NIC, connects the device to the network through what? Through the physical medium or a physical connection, which can be a wired or wireless. Now we know that some devices may contain only a single network interface card, while other devices may contain multiple NIC. It can contain a combination between wired and wireless also network interface card, like our laptop simply. We have an Ethernet port and it has a wireless NIC. So we can connect to the network through the cable, or we can connect to the network by using the wireless communication. Also, not all the physical connections offer the same level of performance. We have a different physical connection types. Each one has a different properties or characteristic or features, so the performance will not be the same. And this is mainly our main points today. We'll discuss the connection types, properties, connector types, and a related topic to the connection types. Now, a quick revision. What we have here actually, we have the encapsulation process from the application to the network layer. We are going to encapsulate the data. We receive it at each layer from the layer before, process it and pass it to the layer before until we reach the physical layer. What we are going to send at the physical layer, if you remember, a data stream. Data stream. Stream of what? Of bits, 0 and 1. So transport bits. The physical layer will transport the bits across the network media. Accept the complete data frame from the data link layer and encoded, represented in a format able to be transmitted through the connection media. This is the encoding. And encode it as a series of, we can encode the bits as a signals, as electrical pulses, or we can use a wave if the connection, or wave signal if the connection is wireless connection. So we have different encoding media depending on what? Depending on the connection, the physical connection we use. So this is the last step in the encapsulation. What's the last step? Encoding the data received from the data link layer as a series of, for example, electrical pulses, optical, or we can use radio waves. So the next device now in the path to the destination will receive the bits, the encoded bits, will re-encapsulate it, the frame, then decide what to do with it. So the web server will send the encoded bits to the client will receive them, decode them, then decide what to do with the data. So whatever we are going to send through the physical layer, it will be encoded data, encoded data. So we can say the physical layer will encode the frame and they create electrical or optical or radio signals that will represent what? The bit in each frame, the bits, sorry, either 0 or 1. So this signal now, or the encoded signal, can be transmitted over the network media from the sender to the receiver. Now let us talk about the physical layer characteristics. Now I have a simple question. Is the physical layer operate at TCP/IP protocol? Yes or no? كانت محاضرتنا الثلاثاء. True or false? Answer this question. Physical layer operate at TCP. True or false? False. Thank you. False. Application, transport, internet. When I talk about the OSI reference model, is TCP. So even as you see here, application presentation session, I'm using the OSI layers here. Transport, network, data link, TCP/IP standard implemented. While physical is a different. The physical layer standard actually are implemented in a hardware and governed by many organizations. So when we talk about the physical layer, actually we are talking about the electronic circuitry, the media, the connectors. These hardware component standard developed by many organizations. It can be a national organization, international organization. So when we talk about the physical layer hardware, what we are talking about, for example, the hardware included in the physical layer, the media, the encoding process, the signaling standards, all of these developed, governed, their standard was established and developed by national, for example, international, or a private organization, such as what you are seeing here. So what we have here is example about organization developed what? A standard for the physical layer. For example, the first one, the ISO, International Organization for Standardization. Second one, EIA. TIA stands for Electronic Industries Association. Telecommunication Industry Association. ITU, International Telecommunication Union. ANSI, American National Standards Institute. And finally, the most famous one, IEEE. How we read it, IEEE, Institute of Electrical and Electronic Engineers. Each one of these organizations develop, focus at different hardware, let me say, or standard operate at the physical layer. So we can say that physical layer standards address three functional areas. The standards provided by the international, national, or private organization addressing three functional areas. The physical components, we are talking about the connectors, the cables, the encoding process, and the signaling. So this is the main three functional addressed by the physical layer standards. Now, physical components, when we talk about the physical components, what we are talking about? The physical, the hardware. So we are talking about the hardware devices, the media, and other connectors that transmit the signal which will represent what? The bits. Remember, any transmitted signal through the physical components representing the bits. Which bits? The bits received from the data link. And when we say bits, it's a binary data. So two values, 0, 1. So hardware components like network interface card, interfaces, connectors, cable materials, cable design, all will be specified in a standard associated with the physical layer. All will be specified as a standard. Length, type, material, how many layer covering, data rate, speed, distance can be used. All of these specified in a standard associated or linked to the physical layer. So what's the encoding? As we have said before, encoding is the process of converting the bits into a form can be transmitted through a communication medium. So encoding here is the process to convert the stream of bits into a format recognizable by the next device in the network. It can be predicted, perceived, and understood by the next device. As you are seeing here, it's one of the examples we are using the Manchester encoding. So this coding, what's the coding? The electrical voltage here. This coding provides predictable pattern, can be recognized by the next device. Example about the encoding here, we are using the Manchester encoding. How we are using the Manchester encoding here? As you see, if we want to represent a 0, encode the 0. 0 will be encoded as the transition, يعني movement from high to low voltage. From high to low at the middle of each time interval. High to low. Now we need to send a 1, a transition from low to high voltage. 0, high to low. Another 0, high to low. 1, low to high. We have another one, low to high transition. 0, high to low transition. This is one of the encoding methods can be used to encode the binary bits, the 0 and 1. For example, when we talk about the Morse code, Morse code will encode the message by using a series of what? Dots and dashes. Each a sequence or a series of dots and dashes will represent specific data. So we can say codes are a grouping of bits used to provide a predictable pattern. These patterns can be recognized by both the sender and the receiver. So the encoding is the method or pattern used to represent the digital information. The encoding is the pattern that we will use it to represent the 0 and 1, which will represent our data. Now, signaling, when we talk about the physical layer, we must say, or we need to know that the physical layer must generate either electrical, optical, or wireless electromagnetic signal. These electrical, optical, or waves, electromagnetic or wireless signal will be used for what? To represent 1 and 0 on the media. So signaling is the way that the bits will be represented in the media. What we call this? Signaling methods. For example, in the optical, we are going to send the light of pulses. So long pulse, for example, will represent 1. Shorter one will represent 0. When we talk about the electrical voltage, low voltage 0, high 1, low 0, high 1, and so on. If you want to represent the 0 and 1 by using a radio wave signaling, it depends on the frequency. Here we are moving low to high, high to low, for example, low to high, low to high. So it depends on the phase modulation here, frequency modulation, amplitude modulation, for example. What's the modulation method used to represent the 0 and 1? So signaling simply is the method signaling method is how the bits value 1 and 0 will be represented in the physical medium, the cable itself, for example. So the method of signaling will vary based on what? Based on the medium being used. It depends. We are using optical cable, we are using a pulses of light. We are using a copper cable, we are using electrical impulses or electrical voltage. We are using a wireless connection, we'll use the waves for signaling, and so on. Right. Now, what's the bandwidth? One of the physical layer characteristics. Bandwidth simply the maximum data rate, maximum amount of data can be transmitted at the unit of time. What's the unit of time I'm talking about? Bit per second. One more time, bandwidth is the maximum capacity, not the actual speed of the transmission. Is the capacity at which the medium can carry data. Digital bandwidth measures the amount of data can flow from one place to another in a given amount of time. What's the amount of time where we measure the bandwidth or the speed of the transmission? How many bits can be transmitted in 1 second? So usually bit per second is the measurements unit of the capacity or the bandwidth. Now, physical media properties, current technologies, and the law of physics play a role in determining the available bandwidth. Usually, we are using the following measurements unit for the bandwidth. The smallest one is the bit per second. Bit per second. We can abbreviate it as PPS, bit per second. Now, bit per second means what? In each second, we are going to send only a single bit, either 0 or 1. We have a kilobit per second. Kilobit per second, as you see abbreviated in this. Now, 1 kilobit per second equal 1000 bits per second. We use the base 10, not the base 2. If we are measuring a data size, we will use the base 2. We are measuring here a capacity, a speed, so we'll use the base 10. It's the standard rule. لحظة. Now, megabit per second, which means 1 million bits per second. Each megabit per second equal million bit per second. 10 to the power 6. Gigabit per seconds, 10 to the power 9. Terabit per seconds, 10 to the power 12 bits can be transmitted per second. What's this? The maximum bandwidth, the maximum capacity. واضح؟ واضح هذا الجدول؟ في أي استفسار عليه؟ Remember, when we talk about the speed, we must use the base 10. We cannot use the base 2 here. Now, please focus. We have a 3 terminology used for the bandwidth: latency, throughput, and goodput. Now, bandwidth is the maximum capacity, okay? What's the latency? The delay. The amount of time including the delay for the data to travel from one given point to another. What's the time taken for the data to travel from A to B? This time is the latency or the delay. Okay? Now, throughput, always smaller than bandwidth, always less than the bandwidth. Throughput, the measures of the transfer bits across the media. The measures of a transfer, any bits type, any type of bits across the media over a given period of time, in a given period of time. Throughput is always less than the bandwidth, always. ما وقفتها أنا. Can you see my screen؟ ما وقفتها يا جماعة.
لا يا دكتور مو واضح السلايد.
مش طالع عندكم الباوربوينت؟
لا مو طالع.
أنا واضح عندي يا دكتور.
لا طالع عند الطلاب وأنا طالع عندي.
أنا طالع عندي. أنا تمام عندي.
اطلع وارجع بسرعة. اطلع وارجع بسرعة اللي مش طالع عنده. طيب الآن عرفنا.
ممكن تشرح مرة ثانية الثروبوت بطريقة أسهل شوي؟
I will. الثروبوت دائما أقل من الباندويث. ليش؟ الثروبوت simply measures the transfer of bits across the media. يعني الاكشوال بيتس، الاكشوال سبيد اللي ترسل بالكيبل، هذا الثروبوت. الباندويث ممكن تكون سرعة النت عندك 100. كم أعطاك لما سويت تستر؟ أعطاك 70. هذه الثروبوت، خلينا نقول الاكشوال. الآن نفس هالترافيك هذه فيها كنترول داتا وفيها مانجمنت داتا، فيها يوزر داتا وكنترول ومانجمنت داتا. فلما نتكلم على كل شيء، على الكنترول، المانجمنت ترافيك مع اليوزر داتا، هذا ثروبوت. وصلت الآن؟ لأنه تشانل سبيد ما راح استخدمها بس عشان أرسل بياناتي. في اكسس كنترول، في ايرور ديتكشن، في سيشن استابليشمنت، فهذا كله راح يستهلك ايش؟ الباندويث. ففعليا هذا مش يوزر داتا ولكن بيتس. فبنقول ترانسفير اوف بيتس، عشان كذا قلت انا all bits. الان نشوف الجود بوت، راح توضح الان. The measurements of usable data. هذا المين ديفرنس بين الثروبوت والجود بوت. الجود بوت let me say the actual user data, the measure of the usable data transfer over a given period of time. معناها الجود بوت always equal لثروبوت minus traffic overhead. الترافيك overhead موجود هنا بالثروبوت، عشان كذا قلنا bits across the network. طيب what's the sources of the traffic overhead؟ ايش السورسز؟ it can be overhead for establishing the session between two devices, acknowledgement overhead, encapsulation overhead, retransmitted the lost bits is an overhead. So the good bot always less than the throughput. Throughput always less than bandwidth. وصلت؟ واضحة؟ معناها فعليا انت لما تستخدم النت بالبيت، السرعة اللي بتطلع لك فعليا اي سرعة هذه؟ سرعة الداونلود اللي عندك، سرعة اي وحدة، اي اسم فعليا بناء على هذا الكلام؟
ثروبوت.
لا، الآن احنا لو شلنا منها للمانجمنت اوفر هيد فعليا الثروبوت، ولكن لو شلنا المانجمنت اوفر هيد وركزنا بس على اليوزر داتا اللي هي اليوزابل داتا، وقتها بنقول هي ايش؟ الجود بوت. وصل الفرق بين هذه وهذه؟ هذه اليوزابل داتا throughput all bits all regardless of the bits type. طيب. Now let us talk about the physical cabling. And the first one is what? The characteristic of the copper cabling. Copper cabling. Copper cabling is the most common type of cabling used in the network today. It's inexpensive, easy to install, has low resistance to electrical current flow. Now, what's the limitation? Attenuation. Attenuation is very important. More distance, weaker signal until the signal is disappeared. We have it in the sound. We have it in the wireless communication. What we are going to send through the cable? Electrical pulses. So further signal, further or longer the electrical signal have to travel, weaker they will get. كل ما بتسافر السيجنال مسافة أطول راح تضعف بغض النظر عن السيجنال تايب. الاتنيويشن موجود. Now the electrical signal, it's very important, this one, inside. The copper cabling susceptible to the interference from two sources. ممكن two sources يأثر على السيجنال والسيجنال will be corrupted. What are the sources? EMI, electromagnetic interference, or radio frequency interference, RFI. And we have another source of interference, the crosstalk. الآن EMI, FRI, it's any nearby signal. A signal in nearby environment will affect the signal through the copper cable, like the radio frequency interference. Now, what's the crosstalk? If we talk about the landline, sometimes when you speak, you will hear another conversation, right? نتكلم على التليفون الأرضي القديم، ساعات بنكون نتكلم بنسمع محادثة ثانية. طيب, what is this? This is the crosstalk. How it's generated, how it happens. Simply, we have electrical signals or electrical current. When the electrical current flows through the wire, moves through the wire, it will generate a small magnetic field. The movement of the electrical current inside the wire will generate a small magnetic field. This magnetic field around the wire can be picked up by adjacent wire. So this is the crosstalk. We have picked up a small magnetic field generated from the adjacent wire. Because of this, when we talk about the telephone circuits, sometimes we can hear a part of other conversation from adjacent circuit, from adjacent wire. What we call this? A crosstalk, تداخل. طيب, how we can mitigate, how we can handle the limitation? What are the mitigation solutions? First one, strict adherence to the cable length. Limits will mitigate the attenuation. Do not, use the cable for a longer distance. Follow the standards regarding the cable length. Now, some kind of copper cable mitigate the electromagnetic interference and the radio frequency interference by using a metallic shielding and grounding. We have a shield, extra covering layer to protect the cables and mitigate EMI, FRI. Now, some kind of copper cable mitigate the crosstalk by having a twisting opposite circuit pair of wires. الوايرز it will be twisted، يعني كل زوج من الوايرز بالداخل راح يكون ملفوف على بعض بنسبة معينة. So we'll handle the crosstalk here. Why? Each cable will generate a totally opposite field than the other cable in that pair. So these opposite magnetic fields will cancel each other. So when they cancel each other, we handle the crosstalk problem. Now, when we talk about the copper cable, we have three main categories, let me say. Unshielded twisted pair. This is the twisted pair. And as you see, the degree of the twisting is different. Less, more, average. Let me say below the max. يعني نسبة اللف بين كل زوج مختلفة عشان الكروس توك هنا. So we have unshielded twisted pair UTP, shielded twisted pair a foil covering, as you see هذا الألمنيوم مثلا, or it can be a net like this. So we call it STP, shielded twisted pair, coaxial cable, like the TV cable. Now when we talk about the unshielded twisted pair, the most common network media, it's terminated by a connector. The end of this cable will including a connector called RJ45. It interconnects the host with intermediary network devices. Connects my host with a switch, connects my PC with a router, for example. What are the main characteristics of the UTP? The outer jacket protects the copper wires from the physical damage. The outer jacket, this one, number one. The plastic covering layer, let me say. Now, a twisted pairs protected the signal from interference. How we will mitigate the cross talk, as I have said, we have a twisted pair. So for example, the orange pair here will generate a positive magnetic field. The white-orange wire in this pair will generate a negative magnetic field when the current flow inside the wire. Positive, negative magnetic fields, they are totally opposite, عكس بعض. So they will cancel each other. So we'll handle the crosstalk in this case. Colored coded plastic insulation. Also we have a plastic covering for each pair. And how we are identify each pair? By specific what? Color. Even the for the pairs is a standard. We use orange, white, orange, green, white, green, blue, white, blue. White, blue means it's a blue and white. Brown, white, brown. The coloring is a standard as well. واضح؟ واضح لما اتكلم على اليو تي بي؟ طلاب معي؟ طيب. Shielded twisted pair. Let us compare it with the unshielded twisted pair. Better noise protected than or protection than UTP. More expensive than shielded twisted pair. Harder to install than UTP. Terminated with RJ45 connectors like the shielded twisted pair. Interconnects the host with intermediary devices or network devices like a switch and router as well. So it's a similar functions. What are the key characteristics? As you see, we have outer jacket, outer cover, outer protection layer, protect the copper wire from physical damage. Layer 2, braided, اللي هو نسيج خلينا نقول, or foil shield, provide electromagnetic interference, radio frequency interference protection. So this is the solution for the EMI FRI. Interference. Foil shield number 3. For each pair, now each pair also has one more foil shield, another shield of wires. They provide EMI FRI protection as well. Finally, a plastic coated insulation for each pair, and each pair identified by a different coloring. Coaxial cable consisting the following characteristics: outer jacket as well, prevent minor physical damage, woven copper braid or metallic foil. Number 2, acts as a second wire in the circuits and as a shield for the inner conductors. A layer of flexible plastic insulation. Number 3, finally the copper conductor is used to transmit the electrical signals. Number 4, بالعادة بيكون من نحاس. So we have different connector types, as you see. Also can be used for the coaxial cable. In general, where we are using the coaxial cable, we are talking about the network. We know we are using the TV transmission. So it can be used in wireless installation, attached antennas to wireless devices. It can be used as a cable internet installation, customer premises wiring. So either a cabling for the DSL, or it can be in some wireless antenna or devices. في استفسارات. طيب، هل مهم المقارنات؟ نعم. هل مهم الفيتشرز؟ نعم. هل مهم الاختصارات؟ نعم. yes. انتبهوا. طيب, let us talk about the properties of the UTB. UTB, unshielded twisted pair cable, has 4 pairs of colored coded coppers. We have 1, 2, 3, 4 pairs of twisted wires together. Pairs يعني زوج. And encased in a flexible plastic shield. The outer jacket, this one, the white one. No shielding is used here. Unshielded. Because of this, it's called unshielded. No shielded is used for the twisted pairs wires. The UTB relies on the following properties to limit the crosstalk. How the crosstalk is handled, we already explained it, but let us read it one more time. We are using the cancellation. Each wire in the pair uses opposite polarity, opposite magnetic field. One wire is a negative, other wire will be a positive. So they are twisted together, and the magnetic field now effectively will cancel each other, and the outsider EMI FRI interference. So the white-orange cable, for example, when we have a current flow within this wire, it will generate a positive, let me say, magnetic field. The orange will generate a negative one. So it will lead that these 2 different magnetic fields, small, remember they are small magnetic field, will cancel each other and will cancel any outside electromagnetic interference or radio frequency interference. Some one of you will ask me, okay, they will cancel each other and cancel any other outsider source. What about the adjacent wire? So we have a problem from the adjacent pair. To handle this, we have a variation in twists barefoot in each wire. اللفات نفسها مختلفة كل بير. As you see, the orange and the white orange twist different than the blue, different than the green, different than the brown pair. So each wire is twisted at different amount, which will help to prevent the crosstalk among the wires in the cable. So cancellation is the solution of the outside source of interference. Different twist is the solution for what? Preventing the crosstalk within the pairs themselves inside the cable. واضحة هذه؟ واضحة النقطة؟ طيب, now when we talk about the UTB standards now, standards for UTB are established by TIA, AIA, 5, 6, 8 standards elements. 5, 6, 8. Now the main elements of these standards are cable type, cable length, connectors to be used, cable terminators, and finally the testing methods. Now, standards of the connectors and cabling, as we have mentioned, provided by Telecommunication Industry Association, Electronic Industries Alliance. So, electrical standards for copper cabling established by IEEE, Institute of Electrical and Electronic Engineers, which rates the unshielded twisted pair cable according to their performance into 3 categories. We have 3 categories for the UTB cable. First one, Cat 3 or Category 3 UTB. Category 3 was used originally for the voice communication over the voice line. Second type is Category 5 or 5E. We can call it 5, Cat 5 or 5E. Now, Cat 5 or Category 5 used for data transmission. It can provide or support a speed up to 100 megabit per second for Category 5. 5E can provide the speeds up to 1000 megabit per second. Finally, Category 6, which used and added a shield, a separator between the pairs. This is the main difference for Category 6 and 5. It supports a higher speed, and the speed can be up to 10 gigabit per second. So Cat 5, 100, 5E, 1000 megabit per second. Cat 6 or Category 6 up to 10 gigabit per second. What we have here, we have the sockets and the connectors for unshielded twisted pair cables. As you see, what we call the connector which terminates the cable, the end of the cable, RJ45. The socket, RJ45 sockets. What we have here, we have an example about poorly terminated UTB cable. We should not have the pairs like this at the end. What we have here, probably terminated UTB cable. وفعليا في مكبس. إذا في حد عمره كبس فيكو cables cross over or straight through cables, we need to order the pairs in different coloring, then we can use that one اللي هو اللي بنسميه المكبس الRJ. ما بعرف في حد عمره استخدمه فيكم، بالذات الطلاب اللي قالوا احنا بنشتغل نتوركينج. طيب, now please focus here. According to the TIA, EIA standards, we have two types of terminator. We have a standard 568A, 568B. Now, what's the difference between them? One of them, or they are used, in order to have either straight through cable or a crossover cable. Now, in general, we have two types of cables. The type of that cable depends on the terminator. Now, we can terminate the cable by using 56A standard or 56B standard. What's the difference between them? The difference is simply the orange, white, orange, green, white, green pair. This is one point. Another point is very important. Do we need to memorize the ordering? Yes. Yes. لازم تحفظوا الأوردر تاع الكالرينج. لازم. So when we talk about A standard, 56A standard, brown, white, brown, pair 4. Orange, white, blue, blue, white, orange, green, white, green. It should be in this order from pair 8 or from 8 to 1 as always. Now, what about B? As you see, no changes with pair 4. We have just swap pair 3 with pair 2. Pair blue also, or pair 1, without any changes between them. So 1 and 4, same. The difference will be between 3 and الأوردر لازم يحفظ فيهن الاثنين. وصلت النقطة هذه؟ راح تشوفوا بالنت أكاديمي أكتيفيتي راح يعطيك البلاج as an activity يطلب منك ترتب الكيبلز حسب الألوان. أو ممكن يكون سؤال ولكن تذكر الألوان السؤال. أو أعطيك الألوان وأقول لك مين هذا؟ هذا أي ستاندرد A أو B. وكنتورك إن شاء الله ستودنت لازم تكون عارفهن. هذه ستاندردز بعالم النتورك. طيب. الآن cables can comes in two types. Initially two types. Straight through, crossover. الآن ممكن أعطيك الديفايسز وأقول لك حدد نوع الكيبل هنا. كذلك انتبهوا. Now, straight through cable, straight cable, or Ethernet straight through. The main standard, both ends, the end it can be 56A or 56B standard. Usually used, or the most common type of network table used to interconnect host to switch, or switch to router, or host to network device. So usually it used to connect what? Different devices. Host to switch, switch to router, host to network device, straight through cable. Now crossover, one of the end standard A and another end standard B. So different termination. Usually used to interconnect their devices, host to host, switch to switch, router to router, for example. Now they are considered legacy now. Why? Now it's considered legacy because most of the network interface card using something called auto MDIX. MDIX stands for medium dependent interference, which used to sense the cable type and complete the connection. What does that mean? Auto MDIX allows the switch port, for example, to automatically detect what's the type of the port is connecting on the other side. So it can automatically detect the type and use the cable as a straight or a crossover. What we call this auto MDIX. Another cable type also the rollover, which is the Cisco proprietary used, or the application hosts serial port to the router, connect to the router through the serial port or switch console port. So the console port actually one side terminated by the RJ and the other part is serial terminator to connect the switch to the PC through the console cable to configure what? The switch or the router by using the CLI, command line interface. So if I ask you, a user wants to connect his device to a switch, the cable that should be used in this situation is straight crossover auto MDIX rollover. The answer should be what? Straight through. Host with a switch, different devices. Switch to switch, crossover. Router to router, switch crossover, and so on. في أي سؤال؟ Almost done. خلصنا يعني. في أي سؤال؟ طيب, now let us talk about the fiber optic. Main properties of the fiber optic, not as common as the UTP because of the expenses involved, the most expensive type, let me say. Ideal for network, for some network scenarios. Transmit the data over a longer distances at a higher bandwidth than any other network media. The fastest one. Less susceptible to the attenuation and completely immune to the EMI FRI. There is no interference at all from the electromagnetic interference, radio frequency interference when we talk about the fiber optic cable. Made of flexible, extremely thin strands of very pure glass. فعليا هو عبارة عن شعر، ولكن الشعر هذا زي شعر البني آدم, let me say, ولكن it's a glass. And even thinner than the human being hair. Not thicker, thinner. انتبهوا, ممكن تكون أرفع من شعرة الإنسان. Use the laser or the LED, light emitting diodes, to encode the bits as what? Pulses of light. So whatever we are going to transmit through the fiber optic medium is a pulses of lights. The fiber cable has a waveguide to transmit the light between two ends within a minimum signal loss. Type. In general, fiber optic cables divided into two main types: single mode and multi-mode. Single mode and multi-mode. What you are talking about? I'm talking about the core, the glass core here, this one at the center. Single mode, one line. Multi-mode, reflected signals as a mirroring. Which one is better? Which one do you think is better? The single or the multi? قبل ما نقول مين الأفضل، إيش تتوقعوا؟ السنجل مود فايبر ولا المالتي مود أفضل؟ الأفضل السنجل وليس المالتي يا عقيل. I will tell you why. Very small core, this is the main features, uses expensive lasers, long distance application used for the long distance communication. It can reach up to 100 kilometers and more. Now, what about the multi-mode? Larger core uses less expensive LED. So we are using the LED laser here. LED transmitted at different angles up to 10 gigabit over only 550 meters. This is the maximum distance. 100 kilometers, 550 meters only. Now, what's the dispersion? Dispersion is very important. It's similar to the attenuation. Dispersion refers to the spreading out of the light pulse over the time. Increased dispersion, increasing the distance, the spreading of the light, means increasing the loss of the signal strength. It's a signal, light signal. Any signal suffering or have the problem of the attenuation. But in the context of the fiber optic, what we call it, dispersion. So multi-mode fiber, MMF, multi-mode fiber has a greater dispersion than single-mode fiber, with a maximum cable distance for the multi-mode fiber is 550 meters only. While when I talk about the single mode, I'm talking about the kilometers, not meters. Now, in general, fiber optic used in 4 types of industry. It can be used as the enterprise network, used for the backbone cabling application, infrastructure of the network, and interconnects the infrastructure devices. We are talking about the main routers and the servers when we talk about the backbone cabling. Fiber to whom or to the whom, which means the fiber connection provided now by the ISPs to the small business or to the homes. So used to provide always on broadband service to homes and small businesses. Long-haul networks used by service provider to connect countries and cities. And finally, submarine cable network used to provide reliable, high capacity, high of surviving in undersea environment. ففعليا we are talking about a very long cable moves through or under the sea at up to transoceanic distances, يعني مسافات عابرة للمحيطات فعليا. Transoceanic distances. Our focus in this course will use only the fiber optics within the enterprise network, which is used to interconnecting the infrastructure devices. But in general, 4 types for industry. Now, same as the UTP cables, we have a terminator, terminates the fiber optic cable, but fiber optic cables have 4 different types of terminators. Now, the main difference among them, the type of the connectors, or these type of the connectors are the dimensions and the method of coupling them. So simply, we are talking about the dimension. How many types we have? We have 4 fiber optic connectors. Straight tip ST connector, which the first type of the fiber optic connectors were used. Second one, subscriber connectors, stands for SC, usually used or it's widely adopted, let me say in the LAN and W or the WAN, connection. And it simply uses a push-pull mechanism. As you see here, we have a push-pull mechanism to connect it with a fiber socket, let me say. We have loosened connector or simplex connectors. It's a small version of the subscriber connector. And finally, we have the duplex multi-mode loosened connector, are a smaller version also, or similar to the loosened connector, but uses the duplex. Instead of a single, we are using two connectors together. So we have 1, 2, 3, 4 connectors. Main difference, dimensions, and let me say coupling methods, how you will plug it with a fiber optic. Now please focus here. Now let us talk about the fiber optic patch codes, the cable itself, the termination. It can be divided into 4 categories. It can be subscriber, multi-mode patch cord, subscriber to subscriber connector, loosened to loosened single mode, as M stands for single mode patch cord. We have straight tip to loosened connector, multi-mode patch cord. So loosened, straight tip. And we have the last one, straight tip to subscriber connector, single mode patch cord. Now, how we can distinguish between them? As you see, there is a standard when we talk about the fiber optic. The standard is the cable color. Now, a yellow color or yellow jack used for the single mode, the color is yellow, single mode, color is yellow. Multi-mode, as you see, we're using the orange or aqua cable or aqua color. Exactly. So even from the color, we can know, is it a single mode or multi-mode? So if you have a fiber optic connection at home now, you can know what's the connector types. If you have a lock, even you can know what's the cable type from its color when you check the in-house modem. Now, finally, let us have a quick comparison between UTP cables and fiber optic cables in the context of the following points. Bandwidth supported UTP 10 megabit per second up to 10 gigabit per second, category 6. Fiber optic 10 mega up to 100 gigabit per second. Distance 1 to 100 meters, 1 to 100,000 meters. Because of this, I said 100 meters when I talk about the single mode cable. Immunity for EMI, FRI, low, high, or completely immune. There is no interference from the EMI, FRI sources. Immunity to electrical hazard, low, high, and completely immune. Connector cost, low, high. Skills required to install it, lowest, highest. And finally, safety precautions, lowest and highest. Finally, we are going to talk about here the wireless media. So we talk about the cables, fiber optic cables. Last communication media is the wireless. No cables, we are going to use the signals here. So on wireless, it carries electromagnetic signals. This electromagnetic signal representing the binary digits using a radio, or microwave frequencies. This provides the greatest mobility option. Wireless number of numbers continue to increase. So the main advantages point with the wireless the mobility. We can connect to the network and feel free to move within the coverage area of that network. Now, some limitation, the coverage area and the environment type. Effective coverage can be significantly impacted by the physical characteristics of the deployment location. Some types of materials, some walls will protect the signal. So it covers, let me say, up to 100 meters or less than that as well. Interference. Wireless is susceptible to the interference and can be disrupted by many common devices. Security. It's an important issue. Wireless communication coverage requires no access to the physical strand of media, so anyone can gain an access to the transmission. I can just get a copy of the data transmission transmitted within that frequency by using special devices, and they can access and read the content of data. So the security is a very important issue. Shared medium. Wireless operates in a half duplex, not a full duplex. What does that mean? One device can send or receive at the time. To access the control, it's using carrier sense multiple access, collision avoidance access protocol. So many users accessing the WLAN at the same time, but only one user will send or receive at the time. Finally, if we talk about the standards, IEEE, Institute of Electrical and Electronic Engineer, and Telecommunication Industry standard for wireless data communication cover both data link and physical layer. In each of these standards, physical layer specification dictate the following. What we have in the standard for the wired network, wireless, Bluetooth, WiMAX, Zigbee, and so on. Data to radio signal encoding methods, frequency to be used, and the power of the transmission. For example, when we talk about the Wi-Fi, we are using either the 2.4 or the 5 gigahertz standards. Signal reception and decoding requirements, antenna design and constructions. If we want to mention some wireless standards, when we see IEEE 802.11, 11 it directly means it's a wireless technology. IEEE 802.3, wired LAN, not wireless. And remember, each standard has a family of versions, many versions, not a single one. For example, for the wireless ABG standard, I think EN, EA standard. So they enhance the modulation techniques and use different modulation methods within this family of standards. 802.15, we are talking about the personal area network or the Bluetooth. 16, we're talking about the WiMAX. Use a point to multi-point topology to provide a broadband wireless access, home network or Zigbee, smart homes. 802.15.4. So low data rate, low power consumption communication, primarily used for the Internet of Things application, device to device within a short range of communication distance. Finally, in general, for the wireless local area network, we need the following devices. Access point, wireless access point, by the way. Access point concentrate wireless signals from the users and connect to the existing copper-based network infrastructure. Usually, the access point will be connected through a cable to the wired network. And the access point will control and manage other devices through a wireless connection. So the access point can be considered as the interface here between a wireless and wired network. This is the infrastructure network for the wireless. So always the access point will be linked through a cable, using a cable, existing cable, to connect to a LAN network or to connect with a broadband, for example, cable. Now, how we can pick up the signal and become a part of this network? We need a wireless NIC adapter, wireless network interface card. Provide wireless communication capability to the network hosts. There are a number of WLAN standards. When purchasing the WLAN equipment, ensure the compatibility and the interoperability. You can use different wireless devices at your home. خلصت. Okay, but make sure it's based on the same standard in order to be able to work and implement on the same environment. This is the end of model 4. We have done